Go live in 3, 2, 1.
Yes, hello. Welcome to our next session in the area of SPS 07, HANA 2, SPS 07, with a new What's New session about mission critical data center operations. We would like to present today in this hour of interesting news we have right at hand for you. With me are two of my colleagues. For the first part, we have Srboljub Dave. He is responsible for backup and recovery. Then myself for HADR and infrastructure, and Ruediger Karl for the workload management and NSE native storage extension part. So welcome here to this session, and without further ado, showing the disclaimer shortly because we are talking about future developments here and there. I would like to show you the agenda. So first part will be backup and recovery, as said. We have also a part about persistent memory and the developments we recently have seen within the infrastructure and system replication part, and afterwards native storage extension and workload management. As you can see, with the links here on the slide, and as usual, the slides are also provided later, you can directly go to the SAP blog showing many other sessions available to dive deep into other topics of SPS 07. Here we are talking about sharing. Okay, I hope now you can see my screen. Our agenda, as I said it just, so here you find the links to the SAP blog talking about SPS 07 and all the other sessions you have now available and will be recorded over the next days, and the release note, which is bringing you some more details. For example, which operating system is now supported with SPS 07 for SLES and RHEL, so SUSE and Red Hat, and following things to know which might be important. Okay. So the first part, I hand over to Szerbo to continue with the backup and recovery part.
Thank you, Ralf. So in total, we have two new features. The first one is retain archive-specific data backups for long-term storage. So with that feature, you can, it has been requested for some time now. And with that feature, you can retain specific data backups for long-term storage. It will actually allow customer, for example, to keep specific backups for financial year-end closings. And the backups will be kept and not will be deleted by the retention policy. So that is the benefit of it. And this feature can be activated for existing or for new backups via HANA Cockpit. Okay, so next slide, please. And the next feature is a bit smaller. Actually, it's an enhancement of an existing feature. Now, HTTP backup check also works for encrypted backups. With HTTP backup check, you manually check the integrity of your backups. HTTP backup check notifies you if any errors were detected in the check part of the backups. And now with Spec 7, it will also work for encrypted backups now. Okay, so that's it from my side, Ralf.
Thanks a lot, Szerbo. So two important new developments we have here for the backup and recovery part. So let's move forward to the next in the area of persistence infrastructure. Here we have some news about persistent memory. You know, this technology from Intel we released several years ago already, supported by several generations of hardware within Intel's offering. You see on the right side the different categories or the different layers, Cascade Lake with Apache Pass, Ice Lake with Barlow Pass, and it was planned from Intel to offer Sapphire Lake with CrowPass, the Optane technology behind it, but this was recently cancelled completely. So this is really sad to see, because the technology we really could use on the HANA side. Typically, it was consumed by customers who have a demand for huge systems, something in the area of 8 to 16 sockets. Then it made a real difference in the cost at the end of the calculation, because the PMEM modules were a little bit more cost effective at the end. Yeah, but this is now, more or less over. Still, of course, we have Cascade Lake. You can still buy these setups. Please contact your hardware partner of choice, what he's offering here. Some partners decided to go away from Intel Optane completely. Others are still offering it. So make sure that you get in contact with the hardware partner. So as shown on the left side in this special color, you see that Ice Lake and Cascade Lake will be the last hardware versions which are supported with Optane memory. The only problem is that Cascade Lake is only offering the big instances. Ice Lake was only released for dual socket designs. So very big installations are not possible here with Ice Lake because of these limitations. So if you are looking still for these options to use PMEM, then you would need to decide for Cascade Lake. What is the follow-up technology? And it is also mentioned here on the slide. It's a CXL, and CXL is a technology based on a huge foundation of partners. It's not only one, like with a persistent memory Optane from Intel. Here we had it very simple for SAP. If we had a problem, we could connect Intel. Now with CXL, it's a huge group of partners, many options, probably in the future, not yet. The technologies are developing over time. The big benefit is you are using the PCI Express bus for this technology. You can spare the very important and valuable DDR-RAM slots for the normal DRAM pieces, because you still need DRAM here. And the new CXL cards can be put in the PCI Express bus, as you know it, even from your own PC, maybe, if you still have one. So the technology is based on PCI Express. You see in the table here on this slide that the throughput, the bandwidth is increasing fantastically over the last generations, and they are still compatible. And this is the most and biggest asset here, that you still can communicate with the Gen 6 card, with the Gen 1 card, because it's such a flexible technology in place. So, of course, this is into the future. We still have some time until this technology is in reach. Of course, first specimens are available, but it will still take some time to release this at the end. What else do we have in the area of persistent memory? We have introduced a little bit more monitoring capabilities, especially if you have critical or difficult situations. Why is persistent memory here and they are slow? If we need a deeper view into it, we needed a high frequent monitoring for that. And this is based on PCM technology from Red Hat and, from Intel. PCM needs to be installed for that. And with that, we have this high frequent option to look into what's happening over there in the persistent memory place. Next to that, we have partition properties for PMEM, which we can define while altering the table quite simple. It's documented. You find it later on, the details in our SAP help portal to dig into that. This gives you, of course, some possibilities right away from the beginning to define which partition of a huge table is supposed to go into the PMEM or non-volatile memory, as it's also often named in our documentation, so that you are aware of these two different names you might see here for the same thing. Okay, that said, let's go further. We have also some monitoring information in the system table sys.m_table_partitions, where we can see very easy in the system table which partition is right now located where. Is it in a part of the persistent memory, and which size it has in total. This is now inside of this system table available. And helps to interact with that. On the right side, you see a small example with which you can generate these kind of situations and see what's happening if you put this or that partition on PMEM or in DRAM. Okay, and last piece here in this part is about topology. Recently, we had some, you could say, nasty situations while topology was not in a consistent state anymore. This typically comes up in situations of takeovers, that after a takeover, the topology is somehow crippled. And to find this source of a problem closer and make it aware to our customers that something can be inconsistent here, wherever. We have now an alert, which is shown here, alert number 145. It's also mentioned in the troubleshooting guide. You probably should know. If not, please have a look. The troubleshooting guide is very helpful for these kind of situations. And this alert will, as the name says, alert you in case these inconsistencies are found in the name server topology. And the typical way of dealing with it is please contact our SAP support so that they can take actions and figure out where is the source of this inconsistency in the name server topology. Okay, that said, we will continue now with the system application developments we have here in place. First one is an extension for our, you could name it API, but we name it HADR provider hooks. These hooks give us a possibility to interact with the outside world in case of takeover scenarios, takeover situations. And with these hooks, we can give information out to the cluster managers, for example. And one of them is SR service state changed, as the headline shows here. And this one was extended to notify our cluster manager partners and customers who are creating their own kind of cluster manager. It's also possible, of course, that certain services might be in a defunct situation. Defunct is typically happening, or the status is typically happening if an index server is crashing or you are shutting down an index server. And during this defunct times, the index servers, if it's not crashed, will clean up the DRAM he used. And you know, HANA can be very big, and the defunct can take some time. Of course, in SPS 06, we did some optimizations here to make it faster, but still we are talking about 1 to 2 minutes. But in takeover scenarios, it might be important to know that this defunct processes will never come back. So cluster managers can take action much earlier. If they see the defunct right away, they could initiate a takeover and let the defunct finish, the process finish to offline at the end, while the takeover is already happening to the secondary side, which is fully loaded and can take over. So if you are interested in creating your own code, your own cluster manager, the code snippet on the right side, the code example might be helpful for you. And in the lower part on the right side, you find the trace output. Okay, next one, system application again, as mentioned, and the headline tells it already. We are talking now here about Delta data shipping. Delta data shipping is one of our oldest, or is the oldest replication technology we were offering, where the HANA kernel is taking care of the replication process. And you see here this small image on the right side showing the primary and the secondary side. And the big advantage of the Delta data shipping, this very old replication mode, is that, as it is shown here in the middle, that the HANA shadow process you need on the secondary side can be shrinked heavily, made as small as possible. Typically, it's something like 10, maybe 20% of the box, of the resources of the box, simply because the replication is not only replicating the log and assessing it on the secondary side, it's also replicating the Delta data. And you might say, okay, you are transferring the information twice here. Yes, it's true. But it allows us to have this very small secondary here, this shadow instance, you could name it, on the secondary side, which allows us to have a huge non-prod area to use these free resources for something like a sandbox or a QA system, you name it. Delta data shipping, as being the oldest replication mode, is not yet sunsetted. It's still supported, and we want to streamline it. Here, we want to make the displayed use case, as you see it in the picture, the default and only one. So if you say, I would like to preload the secondary box to a full extent, to 100%, then we strongly recommend to switch to the continuous log replay. The continuous log replay technology is much more efficient when it comes to transfer. The network traffic is much smaller, can even be compressed on the log side heavily, because the log is performance optimized with HANA, not state optimized. And with that said, this operation mode, as you can see it, minimized shadow or secondary and maximized non-prod use will be the only one in future. So this only takes, in the feedback from our customers who anyway use this as the only use case. And as soon as anything else is needed, continuous log replay is anyway used. Next part, we have a new parameter which enables takeover with uninitialized volumes. And you see here also the parameter in full size. This parameter is a Boolean one, true, false, and allows us to have a lazy or relaxed, you could name it if it's set to true, or a strict operation mode. The background or the situation which is targeted here is a multi-tenant system. So typically with a multi-tenant system, you have a primary side with several tenants, you have a secondary side with several tenants, and you could have a combination of prod and non-prod. And sometimes you might say, okay, this non-prod tenants, they don't need to be replicated, and then you switch off the secondary wherever. So because you say, I don't need the traffic, I would like to spare the traffic and so on. But if you then do a takeover for the whole box with all the tenants on top, you would fall over to a not running tenants for this non-production system I talked about, where the secondary was switched off. And you might lose then content. If you then start up this tenant again on the secondary side, it would have a very old state, of course, because it was shut off and didn't get the last changes from the primary side, and you might lose business data here. So this is the background for this parameter. We would like to warn you as a customer that you have such a situation, and this is the reason why the default setup is false, simply to have the strict setup and give you the chance to react in time to start up this secondary tenant, which was switched off, so that he gets the latest changes from the primary before you finally do the takeover. And the next one is also a little bit of an extension. You probably know the table M service replication, and based on that table, we also have system replication status PY. And here in this system replication status PY, you have a new output column, secondary fully synced, and a similar named column also in the M service replication to give you feedback that the replication is, as the column says, fully in sync. This feature can be executed right now only on the primary side, but it might still be very useful for you if you say, okay, I would like to have a decision for a takeover, and for that you might use this node here to give you a help when and how to decide when it's good to execute a takeover. And this column then tells you, yes, you are safe, everything is in sync, and you can trigger the takeover right now, because the whole system application, all services related to that are in sync and fine for the takeover. What's not yet there and would be good, and it's now also in our backlog, is to extend this feature that you can run the system replication status PY also on the secondary side of a replication if the primary is not available anymore, let's say crashed, hardware broken, whatever. That it would be good to know up to the latest point in time of the replication that this was already or still in sync for until this latest point in time, and then you are safe to trigger the takeover and not losing anything. There are cluster managers who do the same job on their end. Here we have now an option also on HANA end, HANA-driven solution for that. And as said, in our backlog, we have this need to run this system application status PY also on the secondary side. And the last chapter here is again about system application and in combination with security. You probably know, if you are using HANA already for some time, that system application is using already today, before SPS 07, TLS and SSL, but not for encryption, mostly for identification. So the certificates coming with the TLS, SSL, they are used to identify the counterpart for a replication. So if you want to start a replication from one host to another host, this other host is supposed to be the secondary. He needs first the certificates, and you have to transfer them by hand with the SSFS, for example, over to the secondary, so that the secondary HANA instance can open up this secure store file system, and from there get the certificate and send it over to the primary to identify itself. This is of course still used, but now we extending it to a way that always encryption on is possible. Right now, so before we often only used the identification. Now with SPS 07 by default, encryption is always on here also for system replication, and helps to ensure the secure operation between primary and secondary. With that said, I would like to hand over to Ruediger to continue with the next pieces.
Yeah, thank you, Ralf. And let me share my screen first. And hope you can see it now. All right. So Yes. So what's new for the native storage extension in our SAP HANA database with support package stack 7? The native storage extension was introduced with HANA 2 SPS 4. So it's a quite long time that we have this technology in the market with the database. A native storage extension, just as a refresher, is a built-in technology to manage historical data in our database. And historical data are most commonly not kept in memory for all the time. So HANA has some smart mechanism to unload these kind of data to disk and to just reload them into memory in a very smart way when they are requested by queries. And then they are unloaded when they are not used anymore. So this is native storage extension in a very, very short description. And with SPS 7, we introduced a lot of new innovations. And let me introduce them in the next half hour. So first, we have improved our monitoring for NSE. You know, we have the HANA Cockpit as our administration tooling for HANA. It's a web-based tooling, and the HANA Cockpit has another versioning. It's SP16 that comes with SPS 7 of HANA 2. So don't be confused here a bit. There's another release cycle for the cockpit more frequently. And with the SPS 16, we introduced some new backend monitoring into the UI. And you see here an NSE card that gives you an overview about all the important KPIs that are required by the administrator to see what's going on in NSE. And so first of all, what you see is that you know what is your physical data size on disk for the column store. And you know we have a row store as well in HANA, but NSE is only enabled for column store tables. Just to keep that in mind. And what you also see is the portion of data that are page loadable. So page loadable is a load unit description for NSE data. Column loadable is the load unit description for in-memory data. So please keep also this in mind, that when we talk about page loadable data, these data are NSE data. So you see the portion here as an example is about 30%. 30% historical data that we have enabled for NSE, and you see it immediately with this card in your launch page in the HANA Cockpit. And what you also see is what is the buffer cache size for your NSE data. And the buffer cache is the mechanism in HANA to load or to reload data into memory and to unload data to disk. So it's a kind of caching. There we say buffer cache. And the buffer cache has a specific size in HANA, in the HANA memory, that you can configure. And you can configure the buffer cache per host. So what does it mean? It means you have either a scale-out system with multiple hosts, and you can, for each individual host in this scale-out system, you can define individual buffer cache sizes, because even in a scale-out system, you can have a dedicated host for historical data. So that's a kind of usable or beneficial scenario for multi-host systems, and where you have a dedicated host for historical data, which is maybe a bit different in the handling for high availability for other things, and you can configure that also in your topology. Another one is that you have multiple database container systems, the so-called MDC HANA database. And for each MDC database in the HANA, you have your own buffer cache size. So these are the two possible scenarios where you have individual buffer cache sizes per host. So therefore, you see them in the card, and you can select host by host in this card. You see here maximum size of the buffer cache, the allocated size and the used size, and I come to that later what it means, but actually the maximum size is the buffer cache size that can be allocated at maximum in your system. Everything that goes beyond this maximum size is not capable to load data. So that means you need to increase this buffer cache size. Then, if you see that data cannot be loaded by the database. What you also see is the NSE Advisor. It's a tooling in HANA SPS 7 and also 6 and 5 that gives you the possibility to identify data in your database that are eligible for NSE. That means they are not frequently accessed in your daily workload or weekly workload, monthly workload. The advisor is monitoring these access activities and then gives recommendations which data are eligible for NSE. So quite useful tool. And we have also some new innovations in SPS 7. And what we also did is we extended the buffer cache monitoring specifically. That means what you see here you don't see not only the current buffer cache size and the current usage of the buffer cache, you see also some historical information about your buffer cache. So what was the buffer cache size in the past? How was the buffer cache used in the past? So what top consumers? So what tables have been loaded since 2 weeks ago? At which point you have seen an increased size of the allocated buffer cache size, or where you have seen and monitored also an increased I/O read size. So that's also new in SP16 with SP7 that you can monitor the I/O read size of NSE data in your system. And you see they could be quite high because the buffer cache loads and unloads data, and it depending on your historical data and depending on your queries, you can get some I/O traffic which should not exceed the capabilities of the I/O controller, which decreases finally your performance. So that's something that you should observe. And if the I/O read size goes up and explodes, then you need to react and configure and fine-tune your buffer cache size. So it's another indicator to fine-tune your buffer cache size. What you also see here is out-of-buffer events. This is when the max buffer cache size is exceeded exactly. Then these out-of-buffer events are raised, and you see them here as well. The next one is that we introduce these I/O read size not only in the I/O in the UI, sorry, in the UI of the HANA cockpit, but also in our monitoring views. And you see here we have the monitoring views and buffer cache statistics for the buffer cache, and also for the host buffer cache statistics. And what's the difference? Difference is one is the monitoring view for the current buffer cache monitoring for the current buffer cache KPIs, and the host buffer cache statistic, that's the historized view. This is all what you can get from the past. So you can go back in the history up to 42 days to see all the data in the past. And you see in the right column here, in this example, that's a screenshot that I took, right? You see an I/O read size in bytes, so you can do another query here to get a better visualization in the output. But actually, it's the same number that you get with the UI of the HANA cockpit. What is not in the HANA cockpit is that you can even get the I/O read size per statement, and that's also new in SPS 7. So that we extended the monitoring views for the SQL plan cache and also for the historized view of the SQL plan cache to see what kind of I/O has been raised by the buffer cache for NSE data with a certain statement. So that is quite useful. And with the next HANA Cog version, SP17, no timeline yet defined, but in SP17, definitely we will introduce this information as well in the UI. So that means you go into the buffer cache statistics, you see the I/O, you see the tables, you see the statements on the tables, and you see the I/O read size per statement on these tables that are consuming the buffer cache in NSE. So it's a quite detailed analysis what happens in NSE. All right, so what else did we introduce with SP7? And this is a quite interesting innovation. We made our buffer cache elastic. So that means the buffer cache will grow and shrink dynamically. That means in the following. You have a buffer cache which is completely fresh. So you just restarted your system, your HANA database. So the buffer cache size, the allocated buffer cache size is 0. So, and even you have configured a maximum buffer cache size of, let's say, 70 megabyte, whatever. The initial size is 0. That means when you do nothing with NSE data, it remains 0. So no memory is claimed or allocated in HANA. So don't worry. Don't worry. We do not pre-allocate any memory for the buffer cache with NSE. We grow with the queries, with the requests, and we grow up to the maximum buffer cache size and allocate memory dynamically. What we introduced with SP7 is that the buffer cache will dynamically release these memory after a while when no queries are executed anymore on NSE data. So this allocated memory is released. This didn't happen before. So in SP6, what happened is that the buffer cache allocates memory and claims this memory up to the next restart. So that means the buffer cache is managing this memory pool for itself to reload data and to load data into memory. And this is not very optimal for an efficient memory management because let's say you have a peak workload on NSE data once a week, once a month. It would be nice or good that the buffer cache will release this allocated memory after this peak workload, so that this memory is free for other activities in the database, in the HANA in-memory database. So we have introduced a new parameter that you can configure, and this parameter is the unload threshold. And the unload threshold is a kind of low watermark, say that, where the buffer cache is releasing memory until this unload threshold is reached. And so that means whenever new data are reloaded and exceeds the unload threshold, new data or new memory is allocated. You see that here in the green size when after a while when the memory has been released. You see this orange line, and then you come to a new query, to a new peak workload size, where the unload threshold is exceeded. So new memory is allocated, and after a while, the buffer cache will just release this memory again up to the unload threshold. So the unload threshold is to be defined in percentage of the maximum buffer cache size. And the initial guidance is 80%. So 80% of the maximum buffer cache size is the unload threshold, but it's up to the workload and up to the customer system, what unload threshold you will define. It's an INI parameter you define in the HANA database. Yeah, so that means more automated NSE behavior in your database without interaction of the administrator. All right, what next? Next is the NSE advisor. I just mentioned that at the beginning of my talk, that the advisor is a tooling to give recommendations for NSE data, or let's say for data and memory data that are eligible, or that is eligible for NSE. And you know, the NSE advisor is a tool you can configure to be more selective on the recommendations. You can say, okay, please consider in your access statistics only objects with a given object size, right? That means only tables which are larger than 1 gigabyte or 10 gigabyte. Only those objects should be considered by the advisor to express or to generate some recommendations for NSE. So that means all the tiny objects are not considered because the benefit is not that much. And there are other parameters for the NSE advisor to make these recommendations more selective. And what we have seen is that for customers, it was quite difficult to understand why the advisor was not recommending a specific table that the customer has assumed upfront because of, you know, some knowledge about the usage, about the applications running on HANA. So some tables have been identified upfront, maybe due to other knowledge, and the advisor is not recommending these tables. And with a new monitoring view, you see that's the MCS NSE advisor details. You have not only informations about all the objects that have been considered, calculated based on access statistics. You see also the skip reason why a recommendation has not been generated because no access count. So a table has been accessed, but some of the columns within the tables have not been accessed, and so there is no access count. It's just one skip reason you see in the screenshot. Or the scan density is not clear, or let's say, yeah, it's not clear for the advisor to generate a recommendation that this object is an NSE object. Or the other reason is the load unit of this object is already matching the recommendation. So no recommendation needs to be generated, or an object is smaller than the configured min object size. So these are the skip reasons you can see from now on in this monitoring view. Additionally, it's not in the UI of the cockpit yet, but it's at least in the backend in a monitoring view you can use. And yeah, that's also something we will introduce in SP17 of the cockpit. All right, what else? Yeah, you know, you can run the advisor from time to time, or for specific workloads after each other. And with SP6, what happens? The advisor is overwriting the recommendations that have been generated before for other workloads or for other time periods. And this was a bit annoying for customers that they could not persist these recommendations. And unfortunately, we couldn't make it in to bring it into the backend with SP7. That's something we have in our backlog for the next release of HANA 2. But what we did is we created an SAP node that is that provides the information how you can create your own customer table And there is also a script you can copy that copies the generated recommendations in your customer table. So that means you persist those recommendations, which objects, which configuration parameters have been used, which time, and all this information. And the customer table itself can be exported to CSV format, so you can share it with others to make a decision for this table or for other tables to make it NSE enabled or not. So that's something we brought in as an SAP node with an attached script you can use. It's your decision, and we bring this function in the next backend release of HANA 2 for sure. All right, audit log support for NSE. You see, there's a couple innovations we have in SP7. You know, the audit log table could be really huge, and it's a quite security sensitive table. So we did here an extension also for NSE, and in cooperation with our security team to make the audit log table page loadable. So that means all the audit log entries are written to this NSE enabled table. So it's not in memory anymore, and you can save a lot of memory. Whenever you need to read the log table, these data are then loaded into the buffer cache as any other table, and then you get the information. So that's one of the requests that we also received from customers and that we now fulfill with HANA 2 SPS 7. Yeah, let's come to the workload management. And NSE, I think, was quite nice to see what innovations we have. Let's see what we have in workload management. Two major topics. We extended our workload class mappings, and on the other side, we also introduced thread limit support in our workload class hierarchies. Very specific topics, so you should be a bit familiar with workload classes and our workload management, and also workload class hierarchies that we introduced in SPS 6, actually. So let me start with the extended workload class mapping. You see on the left side, there is a problem statement from customers. Customers using S4 HANA or BW for HANA or any ABAP application, they have difficulties to map an ABAP program to workload classes in HANA. And mostly these ABAP programs are reports, they have OLAP load, analytical workload, something like that. And customers would like to separate these programs in ABAP from the OLTP workload. And this was not really possible with SP6 because the mapping information of these programs was not granular enough for the HANA workload management. So the application component or the application name is not granular enough because you have many different modules in the application. Application users are sharing the same program in ABAP. So, and these modules cannot be separated within our workload management for these ABAP programs. And also Fury apps, they use always the same names for application component, application name. So here also the granularity was not sufficient. And so we introduced a new property for the workload mapping, and it's the application source. It looks very easy, but we introduced some more quite significant extensions so that you can map an application source name of your program, your report in ABAP, to a workload class. And you see this in the UI of the cockpit. So we introduced this in the cockpit as well. so that you can map an application source, and an application source has a very long name, and so you can use wildcards here as well to map these application sources to workload classes. So very, very beneficial for ABAP programs, specifically for maybe other HANA clients. Not that important because they are more selective with the properties, the application component name or application name are good enough. But for the ABAP programs, yeah, that was difficult to really separate OLAP and OLTP within S4HANA with an embedded analytics and an embedded reporting, whatever. And also for BW4HANA with different reports in BW4HANA. There is another extension in our workload class mapping. It's a tiny one, but it's extremely powerful. So and this has to do with our wildcard character usage. As said before, you can use a wildcard like a percentage character. That's the default character to use it for the HANA workload class mapping. You have to use a prefix before you can use the wildcard. That was the implementation we had in SP6 and also before. And with SP7, you can use the wildcard character for its own without any prefix. So any value for the property will match successfully. And this gives you the opportunity to define default workload classes and to reduces the maintenance effort significantly. So let's say here as an example, you have S4HANA or your ABAP application, and you want to you want to define resource limits for all application users in your ABAP system. And you do this by using the wildcard percentage for the application username. So that means for your ABAP system, you see here the application name is ABAP colon ABC. And for this ABAP system, which is maybe your S4, ABC is the SID of the S4 system, by the way. You have all application users with the same resource restriction. And so you don't need to define workload classes for each and every application user, because maybe there are thousands of users, and this is a huge maintenance effort. And with this wildcard, you do it just once for all the application users. And by the way, database users that are not using the S4 system, they are not affected because they have another database user. They don't have an application user, so that means it doesn't match because it's just for the application users. Okay, just powerful new innovation with workload management with this single extension. And last but not least, what we introduced with the workload class hierarchies, or let's say we completed the feature of workload class hierarchies by adding a total statement thread limit for parent workload classes. As said, you should be a bit familiar with our workload class hierarchies. You can define a hierarchy with a parent and a child or multiple childs, where the childs are inheriting all the total statement limits from the parent. So it's quite beneficial to have a parent where the childs are inheriting all these total statement limits, and each child has its own single statement limit for the individual workload classes. And the total statement thread limit was not supported with SP6, and with SP7 now it's in, so you can really define the complete set of resource limit properties in your workload classes. And we also introduced that in the HANA Cloud Cockpit. You see here in the upper screenshot, you define a workload class BI client, which is a parent. So you have the total statement limits there for threads in memory. And then you have a child, which is name is daily report. The parent is the BI client. and it's not a parent for sure. So that means you cannot define total statement limits on child level, by the way, because childs will inherit this. And you can add individual statement limits from now for these child workload classes, like here the daily report. And this is now the completion of our workload class hierarchies in SP7, as we have the complete set of the statement limits. All right, that's it from my side. Thank you all for joining this call and for your attention and for your interest for SP7. There's it's a very powerful release that we have released with SP7, and yeah, let me come back to your questions. Ralf, I think.
Yeah, we had some questions about mostly my topics going into a very similar direction. One question was about the fully synced, or the first one of these very similar questions, and had an assumption if this statement, or if the primary is not available, the statement cannot be executed. And here my answer is yes. For these difficult situations, it's still very valid to have some kind of a cluster manager, or SAP is offering here Llama as landscape management, SAP landscape management. They also have some monitoring features implemented here in Llama to keep track of the logs positions, redo log positions, to know exactly how far did the primary and the secondary roll forward, and can compare it at the end and give you a heads up. If you now do a takeover, you would lose maybe something or not. So this is all available in different flavors from the different cluster partners, or even from SAP Llama Landscape Management. And yeah, the second question went in a very similar direction. Also here, the answer is yes, a third entity might be very helpful with Cluster Manager, which might sit outside in a different network maybe, and still have the connections to primary and secondary, while the primary and secondary of HANA themselves might not see each other anymore. So a third entity is always helpful here. But of course, it introduces some more effort to set it up and let it run. And the last one was about the coming statement, which you could run on secondary. This actually will be the same statement. So the shown Python system replication status py, it's a standard Python script we are offering from the HADR provider hooks. And this right now today, you can also run it on secondary, but you won't get a result. So with the development we plan for the next release of HANA on-prem, we hope that this will then also on the secondary give you some output. What is the status of a system application? Okay. So I think we are on the top of the hour. So any further questions we could handle offline. You probably know our email addresses. So yeah, let's finish here. Or do you have anything further, Ruediger?
Not from my end. And yeah, I would close the call. And all questions are answered so far. So thank you very much. And enjoy your day wherever you are. And thank you. Bye.
Bye-bye.
Okay,